All right, welcome back. Let's go ahead and write the code for insert. So I have a snippet over here with the same classes I showed you two videos ago. We have our node class, value left and right, and then we have our binary search tree BST class, which just has an empty root to start. Now, I've recorded this video once before, and I was using this sort of basic binary tree structure because it's really hard, honestly, to visualize how this all should look. Like a linked list is easy. You know, you insert something, it should go afterwards, and you end up with this linear list. With a tree, it can be hard to keep track of where things should go. So I recorded the entire video, and then I realized that I had messed up this entire tree. It just doesn't actually make sense, the values that I used. It's not a valid binary tree. So we have 10. On the left side, every value should be less than 10. So that's true. On the right side, every value should be greater than 10. But if we look at 5, to the left, we have values that are less than. To the right, 4 is not greater than. So I should have something like 7 there. Same thing over here. I don't know what I was thinking. 13, to the left of that, 14 does not work. So let's go with 11, for example. And now we have a valid tree. Okay, so let's start by defining insert, which takes a value. And we'll just make that new node to start. So var new node equals new node and pass in the value. And then let's go with the easy win, which is to check, is there a root already? Or is there not a root? Like if we just did tree.insert 10, that becomes the root. There's nothing in there. So we'll just check if this dot root is null. Then we're going to set this dot root to equal the new node, and then return this just so that we get out of this. None of the other code will run because we're returning. I run the code, we look at our tree, we've got 10. Now if I tried to insert something after this, like 3, nothing happens because, well, technically we make a new node, but then we never attach it or insert it. And nothing's returned because this code doesn't run. Okay, so now the bulk of the logic happens in the else portion. So remember the process, if our tree is only 10 right now, this doesn't exist. What we do, we check, is there a root? Well, if there's not a root, then we do this. Otherwise, which is what we have here, the otherwise condition, we need to check, is our value less than or greater than this value right here? And if it's less than, what are we going to do? We're going to check, is there a left? And if there's not, then we put the value right there. Otherwise, same thing on the right side. Now that's the case if there's only one node in there. But if our tree looks like this, let's say we're inserting the number 1. We would check, is there a root? Yes, there is. All right. Is 1 less than 10 or greater than? It's less than. So then we check. We know it goes on the left side. We check, is there a node on the left? If it looks like this, we would put 1 right here. But if it looks like this, well, there is a node here. So then we compare again. Is 1 less than 5? That's true. So we're going to insert it on the left somewhere. Do we insert it right here? Nope, there's already a value there. So then we move down and repeat. So the process involves looping, just like with a linked list. And I'm going to make a variable called current. And current will start as the root. Just like in our linked list examples, current started as this dot head, the beginning of the linked list. And we're going to update current as we go. And I'm just going to add in a while true. We're going to continue over and over and over. So unlike with the linked list where we had a length that we could, you could add a length, but it wouldn't help you here. Length isn't even really the right measurement. You could add like a number of nodes or something, but that still doesn't really help you. So I'm just going to loop while true, and I'm going to break out of this loop using a return statement if we insert the node. So while true, basically our process is going to be, check if the value is less than or greater than. So let's do that now. We'll just do if value is less than, and then current.value. If that's the case, that means it's going to go on the left somewhere over here, but we first need to check, is there current.left? So another conditional. If current.left is equal to null, if there is nothing on the left, then we found our spot. Eventually, like if we end up here, this is current. If there's no left, and the value is less than this value, then we insert it to the left. Okay, so we'll just say current.left equals new node. and then return. We're done. We don't want this loop to keep going. Now this code will actually work only if we insert like 10 and then 5. It's not going to work if we insert something after that, because if we insert 10, that's all that we have. Then we check if value is less than current.value. Well, if this is current, yes, 5 is less than 10. There is no left, so we've set 5 right here. And if we just verified that, if I run this code and I look at the tree, then we look at the root, and then we look to its left, we have 5. Okay, but it wouldn't work if we tried to insert 2 or 13 or any other value to the right or to the left. So all that we need to do, if it is less than 10 or whatever the root is, but there is already a value here, then we need to move current to now be 5. And then we do the same thing. And if there's already a value to the left or to the right, then we update current to whichever one it should be, and then we check again. So really here, all that we need, nice and short, is just current equals current.left. So we're moving to current.left because the value is less than the current value. So if this is what our tree looks like, and we're trying to insert the number 3, we'd start here. 3 is less than 10, so we know we need to look to the left, but there already is a left. So this part does not run. So we update current to now be 5 and do the same thing. This time there is no left, so we insert right here. Okay, so this is just handling the left side, and we could verify that it worked by inserting like the number 2, for example. If we run this, our tree should have a root of 10, the left of 10 should be 5, and the left of that should be 2, but we have no right set up on any of them. So we just need to basically do the same thing for the right side. So I'll do else if value is greater than current.value. If that's the case, we're going to check if current.right is null. If it is, then we found our spot. Current.right equals new node. Return this. Otherwise, keep looking, or update current so that we traverse further. Current equals current.right. And we should be good to go here. See if I have any typos or any issues. Let's now also insert some other values. So 10, 5, 2. Let's do tree.insert 13. Let's do 11 and 16 and also 7. Okay, let's run this. Here we go. We've got our tree. And what should we explore first? Let's go down the right side this time. So here's our root of 10. And to the right, we should have 13, which we do. To the left, we have 11. And to the right, we have 16. That all looks good. Let's check the left. So on the left, we should have 5. To the left of that, we have 2. To the left of that, we have 7. Let's just verify it still works. Let's say we insert, what about 3? Where should that go? Well, definitely on the left side. And we find 2. It goes to the right of 2. So if we look at tree, and we look at the root, then we look at the left, which is 5. The left is 2. And then the right of that is now 3. So we basically inserted it. This diagram is getting ugly, but we inserted it right there. Okay, so it looks like it's working. Let's see, how does it handle, or does it handle, duplicates? So if I tried to insert 10, for example, what happens? Well, I had to restart my browser, or at least this window, because we hit an infinite loop. And I was trying to illustrate that, but I didn't actually think it through. There was nothing to show you looping infinitely. All that you saw or would have seen is just my computer get hung up and me being unable to type. So we got an infinite loop because if I tried to insert 10 or any of these numbers that are already in there, we have this while true, but we're only checking if the value is less than or greater than. Now, how we actually handle duplicates is really up to the special case of what we're doing, the specifics. Some people are just going to ignore them. Some trees just ignore them outright. That's what we'll do. We could just add a check in here to see if the value is equal to current.value, then we will just return false or undefined or something. The other option, though, that you might see is if you need to know, like if we're inserting certain things over and over and you want to keep track of that, you could add a frequency or a count to the node. and you could increment that. So next to each node, we could have a count like this. And maybe we have 4 16s are in there for some reason and 2 10s. So if you needed that, you could do that. But I'm just going to add an if at the very beginning. If value is equal to current.value, then let's return undefined or something. Undefined. Okay, let's try running this again. We look at our tree. Everything looks good. 10, 5, 2. Okay. Let's try inserting 10 again. We get undefined, and if we look at the tree, it still works. Not that, hopefully nothing should be changed. Everything still works. If we tried to insert something other than 10 that's already in there, like 7, it takes a little bit because it does have to traverse the tree until it finds the right spot and it realizes, oh, this is already in there. Okay, we're done. Lastly, some people get a little up in arms about this. You can simplify some of this logic. There's a couple of else's that are unnecessary. For example, here, if value is less than current.value, we check if there's currently a left and we return. And before I had an else here, but because there's only 2 options and we're returning here, we don't necessarily have to have the else. It's just a stylistic thing. So I have both solutions. This one is a little longer, but it's more explicit about things. So there's else's, same thing here. This else as well, we don't have to have. We're checking if the root is null, return. If it is, we're done. Else, well, we don't have to have the else. We could just start. So that's what I did here. But just tiny changes, really. So if you prefer the solution, you could use this one. It's really the same logic, just slightly less explicit, but also less verbose.